The next quiz will be on 6.1 with the counting principles, and I'm going to ask you something similar to what I'm going to really work out one problem but many different questions on with the same setup. Okay, so what we have is we're going to look at six-digit numbers. So anything that I'm talking about is always going to be a six-digit number. Sorry, and so of course the digits are 0, 1, 2, up to 9. We always think when we don't specify, it means the usual digits, the decimal digits. Okay. And again, when we say a number where we normally don't start a number with 0, we allow that. By the way, in fact, when we write fifth, let's say, if I would write, this is a 5-digit number, right? But I can write it as a 6-digit number by putting a 0 in front of it. So in some sense, we're talking about the same numbers. It's just we normally don't pad it with zeros in the front. Okay, but that's just a small thing. Okay, so like ask us first. Let's do the first one here. Start. So how many? It's always the same, right? How many? Start and end with the same digit. Okay, so let's look about how such a number looks like. So there are always 6 positions, right? Such a number, well, I'm going to choose here an x. And whatever this x is, it has to be also my last digit. And then we have the 4 remaining digits, but there's no more restriction. So these could be any digits here, so I'm going to put y, y, y. Okay, they are different digits, right? So I don't mean to say that they're the same. So let me not even write them. Let me write it at that. So how many choices have I have? Well, okay, there are 10 digits, right? So I have 10 choices to choose this one. But then I have only one choice to choose this one. I am obliged to take the same one. So that's where the restriction I get. Now, how many choices do you have for these? Again, 10. There's nothing about the fact that the next number can be the same as the first one. There's no other restriction, right? So each of these choices are valid choices, and they are independent of each other. So we get this is the number that is 10 to the power 1, 2, 3, 4, 5, right? 10 to the power 5, which is 10,000 if you want. Sorry, it's 100,000. Okay, so let's do something else. So how many pairs, okay, I'm not going to write the pairs of 6-digit numbers start with the same number. Okay, so now, so we have 6, but we're talking about a pair, so we're actually choosing 2 of these numbers, okay? And a pair normally means that we order is in a certain fixed order. Okay, so we're going to have to choose this as well as this. Now, whatever we choose to be the first one here, we also are restricted to choose that one here. Okay, so again, how many choices do I have for this one? 10 choices, right? But how many do I have for this one? Only 1. Because my second one has to also start with the same digit. And then for these, I'm free to choose whatever I want, as well as for these. Okay? There's no more restrictions, so I can choose whatever I want. So how many of the ones that I have? Well, that's 10 to the power 6, a million. But what about the second one, the second number? That is only 10 to the 5th, right? Because I have no choice in that first number anymore. In other words, when I'm choosing the second number, I'm really only choosing 5 digits anymore. The first one is already fixed. Now, what do I do with these 2 numbers? I'm looking for pairs. So I have to choose one number, and I choose the other number. Okay? So is this an and or an or, you might ask? Well, it's a pair. So it's 2 things I'm choosing, so I have to multiply 10 to the 6th times 10 to the 5th. Okay? Understand that? That is multiplication. Apply again, because whatever number I chose as my first number, apart from the fact that I have to choose the same first digit, there's no further restraint, okay? So the choices are independent, and I have to give 2, right? So I choose for the first digit, I have 10 to the 6 possibilities, and for the second, number, I have 10 to the 5th possibility, so in total I have 10 to the 6 times 10 to the 5th. It's the product rule here. Okay, so let's do C. It's still always 6-digit numbers. How many start with 1, 2, or have no 0 in them? Okay. So this is an OR here. So now we have to think a bit, when we have a more complicated situation, we better analyze each separately. So let's start with the ones that start with 1, 2. So 1, 2, and then how many? I have 4 more choices. Now, I didn't say that I can repeat 1 or 2. I can repeat them. So I have 10 choices for this, 10 for here, 10 for here, and 10 for there. So in total, how many of these words start with 1, 2? There is 10 to the 4. That's the number of them. Okay? Of the words that start with 1, 2. What about words that have no 0 in them? So again, there are 6-digit words. Numbers. The 6-digit numbers with no 0 in them. So that means how many choices I have for the first digit? Well, only 9. I cannot choose 0. And the same for the other digit. And again, there's nothing about repetition. So I have 999, and again, everything is for the rest independent. So we multiply again. So this is 9 to the power 6. What do we do now with these two numbers? Well, it's an OR situation, which we know often leads to the sum rule. But with the sum rule, we have to be careful. Namely, we have to think, if it's two separate things, if nothing of the first bunch can be anything from the second bunch, then it is just adding. But if there is overlap, then I'm counting certain numbers twice. Let's think about it. Is there overlap here? Yeah, for instance, this would be a number that satisfies this condition, but it also satisfies this condition. So obviously, some of these numbers I counted twice. So now, therefore, we have to look at the common type. Let's call it the common type. That means that start with 1, 2 have no 0 in them. So how does such a word look like? Number look like? 1, 2, and then 1, 2, 3, 4. Now, how many choices I have for this one, for the first digit? Well, I can choose whatever I want. The only restriction is I cannot choose 0. So I have 9 choices here. 9, 9, and 9. So this is 9 to the 4th. Okay, that's the number here. So now we can say, in C, the number is, well, it is 10 to the 4th, 9 to the 6th. This is the numbers that have no 0 in it. But I counted certain numbers twice. I have to subtract 9 to the 4th from it. Okay? So that is how you solve for ORs. So for ORs, I have to be very careful. So let's do another OR here. Start with 2 even digits, or circles already, start with 2 odd digits. Let's say 3 odd digits. Okay. Again, it's an OR, so let's analyze each of them separately. So the one that starts with 2 even digits. So 1, 2, 3, 4, 5, 6. So the restriction is that these two have to be even. Okay. Now, how many choices are there for even? Well, there are 5 even digits, right? 0, 2, 4, 6, and 8. So I have 5 choices here and 5 choices here. Now, it doesn't say anything about the other digits. So for those, I have the usual choice: 10, 10, 10, and 10. So in total, I have 5 squared, 25, times 10 to the power 4. That is 10,000, so that's 250,000. Okay. If you leave it like that, it's fine. That's the first type. Now, the second type, how do those look like? Well, 10, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So now the restriction is on the first 3 digits, and they have to be odd. Again, how many choices? 5 choices. So I have 5 choices, 5 choices, 5 choices. These are restrictive choices, right? I have to take odds here. But then again, I can choose whatever I want. So in here we have 5 to the third. Well, let me write that down perhaps. So that is 5 to the third times 10 to the third. Okay? If you want, that is actually 125 times 1,000. So that's 125,000. Okay. So what do we do now with these two numbers? We order them. But what you have to think about is, so we have to we choose something from the first bunch, we choose something from the second, or we can choose something from the second bunch, but we have to make sure that in doing this, we don't pick a number twice, that there is no possibility for making the number in two different ways. Is there a way of making the same number in two different ways? No, because you either start with even digits. Yeah, I hope you don't get confused by the fact that 5, 5 are odd numbers. I'm talking there are 5 possibilities here, right? I hope you understood what I'm doing here. So that means there is no common. So there are no common here. And so this is really the sum rule. So in the total number will be 250,000 plus 125,000. Okay, 375,000 if you want. Okay. All right, so let's do another one. And in 4 even digits, and in 4, let me write it up. And in 4 different even digits. So again, 6. I hope that while I'm giving you these examples, you don't really just wait until I solve it, but you try to solve it and then look how I'm doing it. This is how you prepare for a quiz, right? So try figure out yourself and then listen to the solution, so to speak. So end in 4 different even digits. So what we have is a restriction here on these guys. These have to be even. Okay, but there's something more. They have to be different. Okay, let's think about how we choose how many choices we have. For the first digit, I have still 10. So I hope you understand. Each time I put a number here, it means the number of choices I have, right? I'm not putting a digit there. So we have 10 choices for the first digit. There's no restriction on that. 10 on this one. Now, the next digit has to be even, and there are only 5, so I have 5 choices. Now, what changes in the next spot? It still has to be even, but I cannot use the previous one anymore. So I have only 4 choices left. There are only 4 even digits left. And then for the next one, there are only 3 even digits left. And for the last one, only 2. Okay? So that's a different here. So this means that is 10 squared times, this is 120. So that is 12,000. Okay? And then the last one, perhaps, yeah, it's very simple. Have no 2 the same digits. Now, okay, I'm just saying that because to show you that you can ask the same thing in different ways. It's really the same as saying there are different digits, right? So that for the first choice, again, no restriction, 10, but then I'm restricting myself now because I cannot choose the previous one. They have no 2 the same. So this has to be 9, this has to be 8, 7, 6, and 5. So that would be, I'm not even going to write it up. I'm going to just multiply it out like that. In the video I told you this actually number is represented as 10 factorial over 4 factorial. See, it's all the products of the product of all the numbers from 1 to 10 except for the first 4. So that's why I divided out again. Okay? Okay, and so let's be same question, but I said these were all about 6-digit numbers. Let's say how many numbers have how many numbers have length 3 or 5? So now they can have length 3 or they can length 5, okay? Let's just look at an example like that. So what I'm building is again an OR, so what are the ones of length 3? Well, a number of length 3 has 3 choices, so 10, 10, and 10 here. And a number of length 5, well, how does that look like? That's, again, 5 choices. 10, 10, 10, 10. So this is 10 to the power 3. This is 10 to the power 5. And what I do with these numbers, I just add them, right? Because there's obviously no way that both I'm counting a number twice, because the either is length 3 or length 5. They're not the same. Okay? Okay, so this is with letters, with numbers, and probably in the quiz I do something with letters instead of numbers. But all of that is really the same kind of principles all the time. Okay, so what I'm actually not doing the division rule here. I'm really paying attention to the product rule and the sum rule, but really the sum rule in its most general form, what we call here. Remember, when we this formula here is the inclusion-exclusion formula, right? Okay.